everybody. Welcome to ShopTalk, episode 13 with Jim and Ken. I'm Jim.
And I'm Ken.
Yeah, hello, everyone. We got another topic to talk about today, which is adaptive modulation. So, we've got quite a few different things about this topic that we're going to show you and cover. And we'll start off with Ken. You want to lead us into the adaptive modulation topic?
Yeah, absolutely. Thank you so much, Jim. Yeah, I get a lot of questions about adaptive modulation, just sort of what it is, what it does, how it works. And it's also important to talk a little bit about how it ties into some other features of the radios that can give you certain advantages. So let's just sort of cover that in general. So first of all, our radios will allow you to work across a range of different modulation schemes. The highest typically being 4096 QAM, which just means the highest number of bits per second, or the highest capacity of the radio. And it usually takes a pretty strong signal, low signal to noise ratio, good weather conditions, that kind of thing, to operate at that high level. And then we have modulation steps down from there, all the way down to generally QPSK, which is a much smaller capacity than the high end, and then all these steps in between. Anyway, so the concept of adaptive modulation is one where the radio is trying to obtain the highest capacity it possibly can manage at all times under whatever conditions might occur. And usually adaptive modulation is going to kick in where it starts to reduce modulation and therefore reduce capacity under adverse weather conditions such as rain or maybe multipath fading, which has more to do with like weather fronts and pressure and maybe evaporation and other things that might be happening in your path that would cause the main signal to be degraded. So if we look at it that way, your radio should be running at its top modulation or whatever it was designed to almost all of the time. But then during these conditions, it'll shift itself down to a step below and a step below and a step below. So that should be pretty, and then when weather recovers, it steps itself back up and it gets back up to that top. So whenever you're doing a design of these links, in our design tool, we'll show you the predicted amount of time that the link is going to spend at the different modulation rates. And you can see, maybe your link is going to expected to run at the full capacity, all but maybe an hour total over the course of an annual year. And then maybe spend a few minutes at the next modulation down, a few minutes at the next, and then all the way down to the bottom, perhaps a few seconds of total outage, something like that. So get used to looking at that screen, and you can go back and look at some of our videos or the videos on the design tool, or just run our design tool, and you'll get a feeling for what that looks like as far as the predicted amount of time and different modulations. And I think that'll help you understand better how adaptive modulation works. So that's the basics. Now let's talk about the next thing. When you're in our radio and you select adaptive modulation, we automatically put in something that we call automatic transmit power control. And this is basically primarily a power saving mode for the radio, where the radio will reduce the output power of the transmitter, but it only does it to a level where it could still maintain the highest modulation it can possibly maintain. So if your design is sitting at full modulation and it can reduce the transmitter by 10 dB, let's say, it'll do that. It'll still ride above the threshold of 4096 QAM and still give you that full performance. As soon as weather starts to get bad, that transmitter will start to pump itself up all the way to maximum to try to hold that 4096 for as long as it can. Then when it can't hold it any longer, drops a modulation, gets all the way down to the bottom, climbs itself back up, however far it had to go. And then once it gets back to 4096, we'll then again start to reduce the transmit power again to try to just level out at the lowest transmit power it can run at the highest modulation it can run. So hopefully that's not confusing. But it's a good feature, and that ties into a setting that you make in our radio that's called fade margin. And we covered that on another topic. So if you want to go back and look at your ShopTalk videos, you'll find a video on fade margin, and you'll see how that relates to the setting of this automatic transmit power control, some alarms that are going to come up in the radio during these events, indications that we basically give you. And then that's related again to the power consumption of the radio. But really what we wanted to try to cover in this short segment was just to have you understand that concept of adaptive modulation. The radio is always working to achieve the highest capacity at all time. And if needed, it will drop modulation, which also corresponds to a drop in capacity, but it always works to maintain that highest modulation at every moment possible. And the radios signal each other on either end. And the directions of the radio are working independently. So it's possible that in one direction of the radio, we can still maintain maximum modulation. In the opposite direction, we maybe have to drop one. That just has to do with like minor differences in the frequencies between the transmit and the receive, and maybe the impact of the weather having a little bit more impact on one than the other or something like that. So in some points in time, they might be running slightly uneven duplex modulations. Usually they sort of even themselves out. Maybe one drops a little sooner than the other, that kind of thing. But you will see that happen as well. We just want to get that concept across. Now you'll see that when you look at some other radios like our 80 gigahertz radio, they don't have quite as wide of a spread of modulation settings. So you may not see all those same numbers. I mentioned 4096 QAM and QPSK. 80 gigahertz has a different maximum and a different minimum, but it's the same concept. So all you have to do is really just look through a list of modulations that are available. And when you set adaptive modulation, you usually are going to set the range of the highest to the lowest to obtain whatever you can do. So with that, Jim, I'll pass it back to you.
Okay. Well, thanks, Ken. Yeah, great explanation of how that works and how those steps work. What I'd like to do is I'm going to toggle over to my laptop screen. I'm logged into some radios. And what I'm going to do is show you those settings that Ken was referring to. So let me get toggled over here. And in the WTM radios, this is under the radio configuration page. So I'll scroll down here. And as we see, we've logged into the radio under radio configuration. If I scroll about midway down the page, this is where all the adaptive modulation settings are. So starting with the regulatory standard, if you're operating here in the US or under FCC rules, you're going to choose the ANSI profiles. If you're operating in Europe or other places around the world that don't follow FCC, that may follow ETSI rules, you'll select that option. And I'll just give you a brief demonstration. If I choose the ETSI profiles, now, if you look at my channel widths, they're much different than what we're used to seeing here in the US. So the size of the channels are different. They can go up to 112 megahertz. Typically in the US here, 80 megahertz is the widest channel we've got available. So I'll go ahead and just switch back to the ANSI profile, and you can see the step size is different here. The next thing you do, we have two settings. As Ken mentioned, we've got a fixed modulation setting, and this is what you're typically going to put the radio into to do your antenna alignment. So by putting it into fixed, it keeps it at a single modulation at a single transmit power level. And normally you set that for QPSK, which is our lowest modulation. Again, that'll give you the maximum receiver sensitivity and the maximum transmit power. So it makes it easier for aligning the antennas to find the far end initially. Okay, but for our case, for the adaptive settings, you'll notice there again, there's a minimum and a maximum range. So we can set this at a minimum of QPSK, and then at a maximum we can go up to 4096, and that's the typical operating mode for these radios. You want to be able to step through all of those, so during fading conditions it will adapt automatically. There may be some cases where I've seen where maybe you are bouncing between two modulations constantly. You're just right at the receiver threshold. Maybe it'd be easier to just force this thing to go no higher than 2048 and it'll stabilize your link. So that may be one case where you want to limit the upper end modulation for some reason. Along with that is the transmit power. Now, because we've got adaptive set, you'll notice as I hover over here, it says the power mode must be for ATPC. It's pretty much grayed out. If you have adaptive modulation, automatic transmit power control is always going to be in effect. And that's so that it can maintain the spectral purity that's required for each modulation step per FCC requirements. If I were to come back here and set this for fixed modulation, I now have the ability to set this also to fixed power levels. So I can just actually set my nominal output power level for the radio. So again, this would be where you would set it for maximum during antenna alignment. Once you're done, you want to make sure you log back into the radio, switch it back to adaptive, both here, and then we've got to adjust our values. It's got some minimum values required. So that's what I had on adaptive modulation as far as demonstration. Any follow-up thoughts on that, Ken?
Oh, no, thanks, Jim. I think we did have that other video on antenna alignment settings. So if you are interested in digging in a little deeper, there's a nice video on the antenna alignment settings of the GUI in one video, and then there's a secondary video where we cover the RSL voltage ports on the back of the radio. So those are kind of all interrelated to antenna alignment. think the key point here is that during antenna alignment, you don't want adaptive modulation.
Yep.
What happens is the radio signal level is bouncing around, trying to jump up to modulation, lowering its transmit power. It's going to give you weird targets. You want something nice and solid and steady. So choosing that QPSK and the high output transmitter is going to give you the best shot of finding the signal and aligning to the signal. And you can always refer back to your design documentation to figure out what that level is exactly supposed to be when you set for QPSK and max power, so you'll know what targets you're supposed to go after. And if you ever have any questions about that, then contact your systems engineer, sales engineer, or your territory manager, me, Jim, somebody like that. We can show you where to find that information.
Yep.
The other is that we did mention that fade margin setting, and if you have interest in that, you'll want to go watch the ShopTalk video on that topic. But Jim mentioned something really briefly about, maybe you want to set it for max modulation of 2048 instead of 4096 or something like that. That does come up if your prediction is such that you're just barely making performance at the top end. You might be better off dropping at top modulation, just having the signal more stable. I've also got customers, I mentioned about the power control and the power savings. I have some customers that might drop that even further down to give them a lower transmit level to achieve a steady state. And if their capacity requirements match up to that, you can save a lot of power consumption by running at those lower modulations, because you can run at lower transmit power and you can reduce power consumption that way. So that's another thing that comes in handy.
Yeah, terrific. Okay, well, that wraps it up for this edition of Shop Talk. Thanks, everybody. We'll look forward to seeing you on the next version of Shop Talk.
All right. Take care, everybody.